All right, well, let's get going. Thank you so much, everybody, for joining us today. My name is Ellie Cohen. I'm CEO of the Climate Center, and we're excited to have the first webinar in our 6-webinar series on carbon dioxide removal, hosted by California Environmental Voters, Project 2030, and the Climate Center. Many thanks to Melissa Romero, Grashina, Diane Doucette, and Bonnie Beniwal for leading the effort on this. As the world navigates the urgently needed transition from polluting fuels towards clean energy, the science is clear. We must also remove climate pollution that has already been dumped into the atmosphere. This call for carbon dioxide removal, or CDR, grows stronger as new analyses find that the global community is not on track to meet the Paris Agreement goals. In this first webinar of this 6-part series, we will explore the science behind CDR, how it differs from carbon capture and storage, what role it plays in broader climate efforts, and why it must be coupled with direct emissions reductions. So why carbon dioxide removal? Why CDR? The science is clear. The Intergovernmental Panel on Climate Change in its 1.5C report 6 years ago gave us a prescription. We have to cut emissions in half by 2030, and we have to draw down between 100 to 1,000 gigatons of carbon dioxide. That means upwards of 1 trillion tons of past pollution we've already dumped into the atmosphere. And as they say, CDR is an inevitable part of this process. In California, the law AB 1279 by Assemblymember Murat Suci was signed into statute as set as a state goal for reaching carbon neutrality by 2045 with at least 85% cuts in emissions below 1990 levels. And then that leaves up to about 15% that would have to be removed through carbon dioxide removal. Our 2022 scoping plan sets a goal of 7 million metric tons of CDR per year by 2030 and 75 million metric tons per year by 2045. There are already 4 California-based projects that have received grants from the Department of Energy's Direct Air Capture Hubs program. And with all these projects in process and some already in a permitting process, it's essential that communities are engaged in this and that communities have a critical role in determining if and how these projects get developed. Finally, many CDR pathways actually provide urgently needed co-benefits for adaptation, from biodiversity, food and water security, to clean air and water and more. So our 3 organizations, the California Environmental Voters, Project 2030, and the Climate Center, have worked together to develop these shared principles as we learn together about carbon dioxide removal and the kinds of steps that should be taken. Number 1, removing past climate pollution from the atmosphere is essential to stabilizing our climate. 2, we must accelerate cutting emissions and phasing out fossil fuels. CDR is not a substitute for direct emission reductions, and it is not the same as carbon capture and storage. CDR projects should be community-centered and designed with input from communities, where these projects will be sited, where transportation of the byproducts will be traveling through. CDR projects must not exacerbate existing pollution and other environmental challenges. And nature-based CDR is critical with its many co-benefits. So now, who's in the room? Why are you here today? We're going to do a quick poll. We'd like to have you each choose one statement that best describes where you are on carbon dioxide removal as a climate solution. I'm going to just read these 4 before we actually start the poll, and you can decide which one best describes where you are. A, I'm unfamiliar with and generally curious about CDR. B, I have a general understanding but wish to know more about CDR to help me make informed choices in my work and my community. C, I have a deep understanding of CDR and wish to dig into the nuances to help me make informed choices in my work and community. And D, I am concerned about CDR impacts and have questions. So take it away. Please vote. And hopefully we'll see some totals shortly. This is our first time doing this type of poll, but we wanted to see where you all are at now. Okay, great. Hope everybody's filling it out. And I'll have to ask our staff who is managing this, do we have a total and can we show it? Oh, there it is. Try again. Let's see if we can bring that back up. And if not, we'll share it later. Oh, there you go. All right. Wow. So we have a wide range of answers here. And I'm not surprised. That's what we were hoping, that we'd have people here for all these reasons. And we look forward to learning with you together as we embark on this CDR webinar series. Thanks so much for filling that out. Before we get to introducing our fantastic speakers, I just want to be sure you mark your calendars for the next number 2 in our webinar series. That'll be on October 18th from 10 to 11:30 Pacific time. And that will be on the wide range of CDR approaches on air, through air and land and rock and ocean. And we hope to see you there. So I'm really delighted now to introduce our excellent expert presenters today. First is Dr. Marcus X. DeVore. And actually, before I start to introduce everybody, I just want to say what I'll do here is I'll do a quick, brief introduction of each of our speakers. They will each present. After each presentation, we'll have just a couple questions and answers with them. And then after they're completely finished, we'll have about 30 minutes for a whole Q&A and conversation together with all of you. So first, Dr. Marcus X. DeVore is a widely published scientist, creative technologist, innovation practitioner, and communicator who serves as a board member with the U.S. National Academies of Sciences and 1% for the Planet. He is currently a senior partner at Ode, where he builds sustainable solutions, products, and algorithms. Thank you so much for being with us, Marcus. Dr. Kimberly Mayfield works with the Lawrence Livermore National Lab's Carbon Initiative, which aims to understand, develop, and implement technologies for the removal of carbon dioxide from the atmosphere. Her areas of focus are carbon accounting for carbon sequestration projects and environmental justice analysis for negative carbon emissions projects. Welcome, Kim. So glad you're here today. And last but not least, Katie Lebling is a research associate in the World Resource Institute's U.S. Climate Change Program, where she leads research and analysis to inform responsible scaling of carbon dioxide removal approaches. She works at the state, federal, and international levels to advance policy recommendations that can enable sustainable and equitable CDR scaling. Welcome, Katie. So glad to have you all here, and I'm going to hand it off now to Marcus.
Thank you very much. I'm going to click some buttons and attempt to share my screen and give a little bit of an introduction to the science of CDR. So let me press the buttons and away we go. What I'm going to hopefully do today is tell you some things that you already know, but also share a few things that you may not know. I've called it carbon removal WTF. Okay, I'm playing around a little bit. This is a kind of abstract and unusual topic, and there can be a lot of confusion around it. I've been working in the area for around 10 years. Now, this is a little bit about me. This is basically my resume. I'm not really showing you this to talk about myself. I want to explain that I'm a scientist and engineer first. That's how I topics. But I have increasingly worked and moved in other areas outside of the lab, outside the academic environment, out of interest, but also because these are the things that naturally come together and collide when we work on climate topics, sustainability, energy, and certainly carbon removal. So no matter which of these phrases appeal to you or what you think is your home base, there is something for you in this topic, and there's a really helpful way that maybe you can plug in. All right, now, I think it's a helpful reminder to start all the way at the beginning and think about what is this climate problem and what are we talking about? Not entirely, but largely we're talking about greenhouse with a healthy side dose of land use change. This is a picture that shows our scientific measurements of the concentration of CO2 in the atmosphere, in the air around us, over time. And when I say over time, I mean going back, in this case, hundreds of thousands of years. You can see it goes up, it goes down, it goes up, it goes down. But recently, it's really shot up. All the way at the right-hand side of this picture, you can see that yellow trace is going all the way up. Two things to note here. One, every person you've ever known, thought of, or even conceived of has lived inside the width of that fat green arrow at the bottom. That means the human race. Second, all the fuss, all of this earth-changing climate change is driven by the fact that the concentration is changing ever so slightly, 0.03% CO2 up to around 0.04%. This is such a subtle change, and how can this be driving all this climate change? That's a very fair question. It's very counterintuitive, but this is the reality. Such a is having dramatic changes on the Earth. And just as a reminder, we know where these emissions come from. As I mentioned, it's largely a greenhouse, or this is a greenhouse gas problem largely, not entirely, and it's mostly from energy. That's why the imperative is to reduce the emissions associated with energy, which is mostly fossil fuels, and to get onto something else, anything else. Okay, this is my quick formula for what carbon dioxide removal actually means. You have to do three things, and they all add up to CDR. First, you've got to capture the CO2 out of the air or the ocean, by the way. It's a gas, it's a molecule, it's floating around in the air. You've got to find some way to grab it. Second, you have to process or clean it up. Sometimes you have to do this, sometimes you don't, depending on the CDR approach, and we'll hear more about different approaches later. And the third and the crucial thing is you've got to get rid of it. The technical term we use for it is sequester. Usually that means injecting cleaned up pure CO2 underground into rock, where we know it should last, if we treat it right, forever. But there is also a small opportunity to sequester it in things. That can be a tree, or it could be a block of concrete. So that's something I want you to keep in mind too. If you do all those three things, you capture it, you process it, you sequester it, you're doing carbon removal. I showed a picture of concentrations of CO2 in the air over time. This is the same picture, now just zoomed into sort of the time and place where we actually live and are talking about. Now, I want to emphasize, this is not data, this is a cartoon. This is somebody just drew this by hand, but it's illustrative of the role of CO2 removal. Now, what we are currently at the left side of the figure, just adding more and more emissions into that open carbon dioxide sewer that we call our atmosphere. We're just blasting it up there every day, every minute, every second. And the whole trick is to stop doing that, get the curve to peak, and come down. If you remember during COVID, we talked about bending the curve. I don't want to bring up bad memories, but remember we talked about bending the curve by wearing masks and washing hands. We want to bend the CO2 curve, and we need to bend it quickly as soon as possible. However, we know that some amount of direct removal, sometimes called negative emissions, there's a lot of different phrases for it, is necessary. So this picture shows the light blue is what we would like to do. The majority of the work is just turning off the taps of our emissions, but we also have some dark blue work to do. That's the carbon dioxide removal. That's what we're talking about today. Well here, but we've addressed some of these already. Why? Why should we do CDR and not some other thing? These are in order of scientific defensibility, in my view. The first is the most important: clean up yesterday's emissions. Carbon removal is the only thing being discussed in all of climate that can do something about yesterday's emissions. That's really important to remember. I'll just emphasize the last point too. This is actually an opinion, not a scientific truth per se, but I believe that if done right, CDR can also be a pathway to developing and enhancing justice in all forms between global north and global south, inside of our communities in the United States and in California and other places. And we'll hear more about that today in another webinars. Now, carbon dioxide removal, I showed you my simple three-part formula that adds up to CDR. I want you to consider the idea that CDR is not a single thing. There are a lot of ways to do that. CDR is more like an outcome that can be achieved in different ways. This is one way. This is actually a California company called Heirloom. They use mineral rocks to take CO2 out of the air. These are basically racks of baking sheets full of rock powder that reacts with the air and takes the CO2 out. Agriculture, farming. We know plants and soils absorb carbon. They always have, they always will. Maintained or managed farms, regenerative agriculture, maybe even spreading certain agents that are biological or not on farm fields can help us increase carbon into the soils, which, by the way, is good for crops and farmers, even if we're not even thinking about climate change. CDR can look like this: a well-managed forest. Trees literally turn CO2 into their bodies. A well-managed forest can be a gigantic carbon sink. These are some of the original carbon sinks on Earth. CDR can also look like this. This is not data. This is an artist's rendition of what could be in the future. A lot of different ocean-going techniques. A lot of these are some of the earliest stages that we know of, everything from planting kelp to directly filtering seawater. These are also potential approaches for carbon removal. And last but not least, direct air capture. This is another cartoon. This is not real. This is something that could be. This is another California company called Carbon Capture Inc. down in Long Beach in LA. Each one of these green shipping containers is basically a giant HEPA filter that lives outside. Okay. How much CDR do we need? This is a scientific chart that shows us time going left to right and how many gigatons of CO2 per year. And the sort of yellowish, orangish plot is hopeful projections into the future about where we might be. But the point is today, we have the gray bar. How much do we need? Way more than we have. How much do we have today? Around 2 gigatons per year. Some people say we need 10 gigatons per year by 2050. Some people say a little bit less. Some people say a little bit more. Zooming in on that 2 gigatons, how much of it is that more technologically oriented stuff? Almost none. These are early stage technologies that we're trying to develop. The majority of the CDR that's happening as I'm speaking, as you're listening, is done by trees, plants, soils. We know they can't do all of it. That's why we're trying to develop novel technologies. Just to remind you what we're thinking about when we talk about CDR, one of the things that distinguishes types of CDR approaches is how long the sequestration will last. Intuitively, you might understand that if you put it into a tree, well, a tree has a finite life. A tree's life might even be interrupted by fire as climate changes. So plant-based, biological-based carbon removal is likely to be shorter duration, whereas things that are based on rocks, for instance, which we know naturally live longer, is likely to have a longer lifespan. I will skip ahead a little bit to save time, make sure we have time for questions. I just want to point out, it was mentioned the IPCC and their response to CDR. Carbon dioxide removal has not always been a popular scientific topic. In fact, over time, it has sort of come to the fore. The reason it's come to the fore is, unfortunately, we haven't cut our emissions. Remember the main thing, we haven't cut our emissions as quickly as we would like. This is a quick summary, which I won't dwell on how the IPCC reports have referenced CDR. You can track this through time. These are all public documents. You can see that the scientific community increasingly is moving towards the acceptance that this has to be a part of the picture. And that's a question of how do we do it in the most equitable way. The last thing I will share is some things you may hear out loud about CDR that are either incomplete or just flat out untrue. And I'll stop here. We've heard the first one before. Carbon removal is just carbon capture and storage, like what you might imagine putting on a natural gas facility. This is patently untrue. Sometimes it's confusing to know the difference. Sometimes people intentionally mix them up, but this is just not true. Engineered and nature-based. These aren't incorrect, but I would argue that the more important distinction is how long does the sequestration last? It doesn't really matter whether it's done by so-called nature or done by so-called engineering. A lot of people think it gets too much money and press. I can show data later if you're interested to show that maybe it shows up in news feeds, but it gets a tiny, tiny fraction of all the money we spend, even on mitigating climate. Another idea is that we should only do this after we've done job one of turning off our major emissions. The challenge with that idea is that if we wait until 2050 to start working on this when we need it, it won't be ready. This is the type of thing that's going to take decades to mature. A couple other things that it's just something that Silicon Valley playboys are interested in. It's true, many companies in this world, if they're working in a company format, are funded by venture capital. We can dunk on VCs all we like. I'm not here to defend tech bros, but no, this is false. This CDR has interest and traction, not just in this country, not just on the West Coast, but in Canada, in South America, in Europe, increasingly in Asia, and including in East Africa as well. I think I will close there, say thank you for inviting me. I look forward to questions and discussions, and I'll hand it back to our moderator. Thank you.
Thank you, Dr. Extavor. That was fantastic. Let's just, before we get to our next speaker, direct a couple questions to you, Marcus. My first question here that's come up from our attendees on the chat. You mentioned that the concentration of carbon right now exceeds what is deemed to be at a safe level. What happens if we stop emitting emissions tomorrow? Will we still need carbon removal, or will the climate restore itself? If so, how long will it take? Can you stay on screen, Marcus? That would be great. Marcus, are you there?
I'm here. I may need some help from the host to turn my screen back on. Oh, here we go. Okay, there's the button.
Super. Yeah, thank you.
Back. If we turn off our emissions, what happens? The CO2 in the air will slowly metabolize into the rest of the biosphere. The problem is it'll take too long. Think something like 500 to 600 years. This is somewhat debated, but I've seen very few what I consider credible studies that come up with a number less than that. So the point is, to be blunt, if we don't want to cook ourselves in the next few generations, it's not enough to just wait for the Earth to naturally take care of the CO2. That's how much CO2 we've put up into the air. Answer that question as well, or did I answer that?
Yeah, thank you.
Thank you.
All right, another question for you, Marcus. Is there a risk of CO2 leaking out and returning to the atmosphere when sequestering it in rock or other objects?
Great question. Here's how that could happen. You take CO2, you inject it into the earth. You don't drill a new well. You probably stuff it back into an empty oil and gas well. If the well, now we're getting technical, if the well is not sealed properly, there is a risk of leak. The major public health risk is, I'll just call it what it is, suffocation. You don't want CO2 leaking into your town. The good news is the largest and most sophisticated industry on earth, like it or not, is the oil and gas industry. They know very well how to cap these wells. The leaks happen because companies go bankrupt. To get out of their environmental responsibilities, they walk away from a well or malpractice. Over the long term, the CO2 don't think about a gas in a bubble underground. It actually turns into a mineral and becomes rock over time. We think that process takes decades or centuries. So basically, if we pump it underground and cap the wells right, with high confidence, we should be able to say, it's rock and it'll never come out. But it's the near-term risk that we have to be careful about.
Oh, thank you so much. Just one clarification question about when you were talking about positive emissions. What does that mean exactly?
I'm
It was
not.
on the chart that you had when the light blue on that chart.
Okay. Yeah, I showed sort of like that light blue wave. So what I was showing was naturally right now, our emissions are just growing and growing. Despite all of our efforts, they have slowed a bit, but they're still going up. And what I was trying to say is that once we start to really take a big bite out of those, we want to turn that around, have it come down, and then also add in that so-called negative emissions or CDR. This negative and positive emissions language is quite confusing, but I hope that helps a little bit.
Yeah, that's great. All right, thank you so much, Marcus. That was super, really appreciate it. And we'll come back to you with our general Q&A session after our next two presenters. So now I'd like to bring on Kim. Dr. Mayfield, please take it away. Put your slides up. Thank you so much.
All right, thank you all. Hopefully you all can hear me all right. We're going to zoom in now, okay? We're going to zoom in from the planet to just the United States and California. Now, if you have not read all 5 of these reports, don't worry. This talk is essentially just the too long didn't read version of these, okay? So we're going to talk about carbon dioxide removal in the United States and California and their plans. Now, as Marcus very nicely described to us, why bother with CO2 removal? It's really about trying to minimize the warming as much as we possibly can. So once again, that highlighted part of negativity being necessary to actually limit warming to 1.5 or even 2 degrees Celsius here. And in case anybody was thinking, oh, it's not really our problem, it's the rest of the world. I took this quote from Taylor Swift, just to be really clear about it. This is data from our World in Data, and no, we have been emitting as United States citizens an awful lot of CO2 emissions, and it really is falling on our shoulders here. Here's the United States emissions on the right-hand side and where it comes from. And then we have California here on the left. You can see that they're quite similar in proportions, very different in magnitude. So we're going to be talking a little bit about how the United States plans to tackle this, as well as the state of California. So nationally, we're going to start with the US. What do we need to reach net zero? There's this wonderful report that came out back in 2021, looking at the long-term strategy for the United States and how we reach net zero. And I would like to highlight that on the far left side here, this just large gray bar, this is our net emissions, looking at approximately 7 gigatons of CO2 per year. Now, everything immediately after that, you're looking at decarbonization, decarbonizing transportation, our energy system, land degradation, all things like this. It's not until you make it all the way to the far right that you actually end up seeing the carbon removal. Okay, so this is needed for that final 10 to 20%. So we are doing the priority, which is decarbonization, while also scaling up carbon dioxide removal. Now, once you have removed that carbon, as Mark has said, you do need to store it somewhere. So after you remove CO2, one of our most durable places to store it is in deep, porous rock layers, very, very far underneath the earth, about 1.5 miles or something like that. So this is way, way below any aquifers. We are not allowed to do it in any place where the aquifer could be useful, and only when there are sufficient cap rocks to keep it very well sealed underneath there. Usually, kind of abandoned oil and gas fields. Now, current projects globally can store about 40 million tons of CO2 per year, and we need to scale this up to 100 billion. And that is an order of magnitude difference and then some, which is really frightening. So that estimate came from the IEA. Now, there is a silver lining to this, which is that there is ample storage globally. In fact, even just here in the United States, we have some of the best storage in the world. The United States can actually do 3,000 billion tons alone if we needed to. So this is a figure from the recently published Roads to Removal report, where you can see a geologic carbon storage map for the United States. And you can really think of it here as orange being not good, and then the darker the green, the better the storage is, right? So this is looking at how much it costs to store each ton of CO2. And California alone can store about 0.6 billion. So this is quite a lot of CO2. And if you really take a look at it, you can see that there's quite a bit of good storage, east of the Rockies. But when you look west of the Rockies, there's very limited options. And so California is particularly well endowed when it comes to the Western United States. But really to make carbon dioxide removal happen, you see that California is the best geologic storage here. Now there is this opportunity in basalts, the lighter pink. We won't be going into it because it's not permittable right now. But that is another option that people are very interested in. So we do have to tackle transportation of how to get the CO2 to the storage site, as well as where it's going to be stored. So the United States has estimated that it's going to need about 1 billion tons of CO2 to be stored. And remember, California alone, we've got 0.6 billion of storage. So here is how that CO2 removal piece of the pie compares to all of the emissions that we're currently doing. So if people think that carbon dioxide removal is going to be replacing decarbonization, this is just absolutely not correct. We have so much more decarbonization to do relative to the amount of CO2 removal that we're going to do. But we are going to do our absolute best to reach this 1 billion tons of CO2 removal per year by 2050. This is what the White House goal is. And you might be wondering, can the US even remove that? Sure, we have the storage, but do we actually have the methods with which we can remove this and scale it up in time? And I hope this makes you feel a little bit more hopeful. We can. So this is a figure from Roads to Removal where you see that kind of each region of the United States more or less has different superpowers when it comes to all of the different types of methods. So your ecological methods as well as your geologic methods of carbon dioxide removal and storage. And it is going to cost money. It is not free, but we can do it for about $130 billion per year. I looked it up. This is more or less about the amount that we spend on waste management or taking out the trash. So consider this our invisible trash tax. It's about less than 0.5% of the US GDP. So here on this graph, you're looking at millions of tons of CO2 per year on the x-axis, and then the cost in dollars per ton on the y-axis. You can see the ecological solutions from forest management, as well as several different agricultural cropland management scenarios like cover cropping, perennial field borders, or carbon cropping. Here in the middle, taking up the lion's share, is what we refer to as bikers, or biomass for carbon removal and storage. And then on the far left, you have direct air capture, right? So this is that fan one that Marcus discussed. And then we have more opportunities for direct air capture, but in this figure, we went ahead and cut it off at 1 billion just to really zoom in on what we can do now most cheaply, right? Now, California, they have a goal of 125 million tons of CO2 per year by 2045. California recognizes that its economy is growing, and with a growing economy, you also have growing emissions. And so California is really looking to make a big name in CO2 removal and storage. And you might be asking the same question is, can California itself remove 125 million tons per year? And also, we can. So here are kind of California's superpowers, if you will. So we've got forest management all up here in the blue. But once you're doing the sustainable forest management, you really have a lot of forest biomass, and it is not really safe where it is. I think any of us that followed any of the recent fires could recognize that. So you need to get that forest biomass out of where it is causing danger and move it someplace else. And then those trees, they captured a lot of carbon several years ago, and they continue to do so. So you can actually take that carbon, they have already captured it from the air for you. And you can put it through different processes such as gasification, and then inject that CO2 underground. Here in the green, you have regions that are particularly good for agricultural carbon dioxide removal, as well as having the geologic carbon storage that is necessary for direct air capture to succeed. So direct air capture, we really optimized in our report, being able to do this with local storage, because that's what makes the most sense for it. And then you also have a lot of waste opportunities, right? So we have a ton of waste, and it makes a lot of sense for us to see if we can repurpose that for carbon dioxide removal and storage instead. And similarly to the United States, we can get quite a bit of our carbon dioxide removal emissions done immediately right now. Like you could go and start today with increasing forest management and increasing soil carbon management practices. But then also that biomass for carbon removal and storage, as well as direct air capture, is needed to actually make our way up to 125 million tons of CO2 removal per year. It's going to be of a similar order of magnitude, about 0.4% of the California GDP. So that's not US, apologies, that's California. So about less than $10 billion per year, similar on order to that taking out the trash number conveniently. And now you might be wondering, that report was published back in 2019, 2020. So what has California been doing ever since? Have we done anything on it? Has it actually led to action? And this here is a map that I pulled yesterday from CDR.FYI. They actually have carbon removal projects mapped for the entire world, including the United States, and then it makes it all the way down to the state. So this is filtered down here for California. You can look at a lot of different projects doing different methods of CO2 removal. Feel free to go check it out on their website. But I wanted to highlight a few different projects here on this little timeline, starting with 2020 on the far left, where you've got getting to neutral, actually making it in people's hands. There was this COVID-19 pandemic, so it's okay that we weren't making as much progress during this amount of time. But what's impressive is that then actually coming out of the pandemic, we're able to pass the California Climate Crisis Act, AB 1279. So really saying for sure that California is committing to net zero gas emissions. We need to be doing this as soon as possible, but no later than 2045, as well as SB 905, which is creating the CDR and CCUS programs in California. Once again, as Marcus said, really differentiating carbon capture and storage from carbon dioxide removal. So we need both, but differentiating that there's different ways to go about each of these different processes. In 2022, CAL FIRE and the California Department of Conservation came out with forest fuels initiatives, looking at, as I mentioned before, getting that forest biomass that is far too dense in those dark blue regions and turning them into sustainable biofuels. elsewhere. So here we have mitigating forest fires as well as creating sustainable biofuels. In 2023, we had that first direct air capture pilot plant open in Tracy, California by Heirloom, those baking tray stacks you saw earlier. And then looking forward to 2024, we're hoping to see some new farm bill legislation that includes carbon farming. So keep your fingers crossed for that, as well as DOE funds to actually start flowing for the different DAC hubs, direct air capture hubs in California. So we know that several were already awarded. They've been recognized by the Department of Energy, and now it's just a waiting game for when those funds are actually going to flow to the state. So in summary, the state of the science for the United States and California are very similar to one another. Both need to decarbonize now. That is of critical importance because carbon dioxide removal alone does not do the trick. We need to decarbonize that entire massive majority of the pie. But we also need to start removing CO2, particularly anything that's going to take scale up and permitting. We all are aware of how long that actually takes to embark on. So we need to begin getting it ready now so that it's ready for us when we really need it. And the United States and California can accomplish 10 to 20% of their CDR needs with ecological carbon dioxide removal now, which is very exciting because the sooner that you start, the greater climate impact you have with those projects. The other 80% are going to be what I'm referring to as the geologic CO2 storage methods, right? So the bikers and the direct air capture options. Thank you. And if you have any questions or want to take a look at some interactive maps, visit the Roads to Removal website at roadstoremoval.org. Thank you.
Thank you so much, Dr. Mayfield. If you can stay on right now, let's just stay on screen. We have several questions for you here, and we'll get at least to one or two of them. First, how many miles of carbon pipeline built out would be required in California? Where would it occur? What are the risks to public health and the environment?
I do not know how much pipeline miles would be needed. I don't think that even California has that number yet, because there has not been a plan because California is still reviewing pipeline decisions, pipeline safety, setback needs and desires. California is still working on this systematically as a whole. So I don't have an answer for you when it comes to pipeline distances or lengths. But I can say that CO2 pipelines are something that we know that we can do, and we know that we can do them safely. But the thing is that you also really need to have those projects actually starting to get on board, right? So when you're starting from a very small scale, you can probably just move the CO2 by a truck in the very small scale as proof of concept. But then as these projects grow, when we actually make it to scale, that's when you really do need the pipelines, right? So I look forward to seeing what our state decides.
Thank you. Another question here. Even though trees only store CO2 temporarily, doesn't increasing the number of trees provide a one-time sequestration? In other words, a tree grows and stores carbon, dies, and releases it as it decomposes and is replaced by another tree, which repeats the cycle.
Yeah, I love trees. Trees are great at removing carbon dioxide from the atmosphere. I will be the last person to ever tell you, do not plant a tree. In fact, actually in the Roads to Removal report, we even looked at really trying to speed this up a lot in the southeastern United States, where they have ample water resources and a lot of vacant land, essentially. And we looked at if you were to cycle where you grow a tree and then you cut it and you turn that wood into a long-lived wood product. I mean, the carbon is stored in that long-lived wood product as long as you don't burn that wood. So we looked at doing that with short-term rotational cropping of about 10 to 30 years, and it can make a really big difference. It's just that for California, right, we're really about trying to keep our things from burning and not really about trying to do tree farming here. But for the United States, we did analyze that. I just didn't discuss it in here.
Okay. And well, if you can do this in less than a minute, what proportion of carbon dioxide storage potential in the US and California is nature-based? And does this take into consideration a factor to account for wildfire?
So when it comes to the nature-based, we were looking at about 10 to 20%. But this also, I mean, you can increase that the more that you pay farmers, right? So we had a specific cap in that case of $40 per ton of CO2 is what you'd be willing to pay farmers to implement things like cover cropping. But if you increase that to $100 per ton of CO2, surprise, a lot more farmers are more than happy to take your money and apply cover crops, and that does increase soil sequestration. So it depends more so on how much money our governments would like to spend, and that will make a big difference for how much is stored in ecological storage reservoirs, yeah, early on.
Okay, thank you so much, Kim. Really appreciate your excellent presentation. And if you can go off screen now, we'll have you come back on for our general Q&A session. Thanks so much. And now I'm pleased to hand it over to Katie Lebling. Take it away, Katie, if you want to share your screen now.
Yeah, I'm not able to start my video.
Okay,
Oh,
maybe
no, never mind. The
there you
host
go.
has now allowed
Okay.
me to start my video. Okay.
Thank you. And
Yeah,
you can
thanks
share
so
your
much.
screen? Yeah.
Yes, I am doing that right now. Yeah, thanks so much for having me. I'm Katie Lebling. I'm a research associate at the World Resources Institute. So WRI is a global nonprofit research organization. We work on a number of topics at the intersection of environmental sustainability, climate change, and sustainable development. And so we have a small team that works on carbon dioxide removal within our US program. So that's where I work. And I focus mainly on policy, federal policy options to help scale CDR. So I'm going to talk about a few things. I think reiterating some points that were made, but making them in slightly different ways, hopefully. Around the difference between carbon removal and carbon capture, the role carbon removal plays over time, briefly laying out carbon removal options, and then talking about responsible scaling. So yeah, so I think several people have mentioned this already, but just to reiterate the important distinction between CCS and carbon dioxide removal. So CCS on the left captures emissions at a source. So at a cement plant, at a power plant, and it prevents them from going into the atmosphere. So it's a form of emissions reduction. Carbon removal pulls CO2 directly from the air. So once CO2, and so this can be from past emissions that are already in the atmosphere. And so once CO2 is captured by CCS or pulled from the air by direct air capture, there can be an overlap in the two in the transport and sequestration steps. So I think that overlap is where there's confusion and conflation. However, this overlap only applies to a few types of carbon dioxide removal, namely direct air capture and bioenergy with CCS. There are a bunch of other types of carbon dioxide removal that don't involve CO2 pipelines, don't involve underground geologic storage. So forest restoration, we've talked about, carbon mineralization, marine-based CDR approaches, some of those as well. And so I think this conflation is misleading and unhelpful because CCS and CDR play different roles and have different non-carbon impacts. So the difference is important because yeah, they play different roles, which I'll talk about on the next slide, actually. And then they have these different impacts on the ground in terms of energy usage, water, land area needs, air pollutant emissions. So I think it's helpful to keep them separate when we're thinking about the non-carbon impacts. Also, CDR is much more flexible in its siting because it's generally a new project. So you have more flexibility in where you put it, whereas CCS has to go on an existing facility, so you can't really move that facility. So just to underscore that point again. And I know Marcus showed a version of this graph. I just want to make a few more points on it. So this chart is from the Intergovernmental Panel on Climate Change. That's the world's leading climate scientists that come together every 5 to 7 years to write a report assessing the state of the science. So and then they use that to inform policy. It sends policy signals. So it's very important report. And this one is from 2022, the most recent report that they did. And they reaffirmed what they've been saying since 2018 when they did a special report on 1.5 degrees, which is that we'll need carbon dioxide removal as a complement to emissions reduction. So a few key points I want to point out about this chart. So you see the biggest piece of the mitigation puzzle, the biggest effort that we'll need to bend the curve downward is going to be from emissions reductions. That's moving the blue part of the curve down. And CDR is a complement to that. So the orange piece is below the line. And so we need to do carbon removal now because we've put so much emissions into the atmosphere. It's not necessarily something we want to rely on, but because we've done such a poor job of reducing emissions historically, we now have so much in the atmosphere that there's no way for us to meet our climate goals by just reducing emissions. So we have to do CDR as well. Another point is you can see kind of the darker orange and the lighter orange below the line. The darker orange is removals on managed land, so things like reforestation and soil carbon. This is a pretty consistent wedge over time that we need to maintain, but we just don't have enough land available without taking away from other uses to get the level of carbon removal that we really need. So then we have to look to other types of removals, which is the light orange wedge that you see getting bigger over time. So I just want to point out, it's this evolving portfolio of different types of carbon dioxide removal. And then lastly, in terms of looking at the role over time, before and at net zero, the role of carbon removal is really to compensate for the hardest to abate emissions, those that we don't have technological ways to reduce or we can't address in any other way. And then after net zero, as Marcus said, it's the only way we have to reduce legacy emissions, or all the CO2 that we've already put into the atmosphere that's already causing the worsening impacts of climate change that we see today. And so I think this distinction is also relevant to the CCS versus CDR point, because CDR is the only thing we have to address those legacy emissions. CCS is just emissions reduction. It doesn't do the removal part. So yeah, and then another thing, I know there's going to be a series, or at least one more webinar looking at all the different approaches to CDR, but just to point out that it is many different things. I think oftentimes people just think of direct air capture when they hear carbon dioxide removal, but it's this wide range from afforestation, reforestation, soil carbon sequestration, all the way over to direct air capture on land. And then there's a range of approaches that are being proposed and in some cases beginning to be tested in the ocean or marine environments. So also ranging from more familiar things like coastal wetland restoration to more engineered or abiotic approaches like electrochemical CO2. So just to say, it's a lot of different things. It's not just one thing. And so then I think the big question is, and how WRI is approaching this issue is, if the world's leading climate scientists say that we'll need carbon removal, how can we do it in the best and most responsible way possible? And how can policy help us get to that point? So this slide is kind of some initial ideas we have about what responsible scaling involves. It's not comprehensive. There's a lot of things missing, can't fit everything on one slide. And this kind of climate, people, nature categorization also isn't definitive. There's overlap across those, but just wanted to organize it in some way. And I think there's also pieces relevant to both the planning side and the deployment side of carbon removal. So just to pick a few of these, the first box under the climate side, the right size in relation to emissions reduction, I think relates back to the points we've discussed already about the relative roles of emission reduction and carbon removal. We know that we'll need carbon removal, but we want to make sure it plays an appropriately sized role. We're not planning to over rely on it, and that we're not planning to use it to compensate for ongoing fossil fuels. So one way that we have been thinking about addressing this, and others have proposed as well, or at least one step toward addressing this, is through setting separate targets for emissions reduction and carbon removal, so that it's clear how much reduction you're relying on versus how much removal you're relying on. And that can create transparency and help match the level of removal to hopefully the level of residual or hard to abate emissions that you have left over. And I think, as Kim said, California has AB 1279, which mandates 85% emissions reduction, kind of implicitly leaves the role of CDR to fill in the rest. And other states have laws similar to this, but a lot of states don't. And it's also an opportunity at the national level that some countries are thinking about as well. So on the people pillar, and I think relevant to nature too, and really across the board, is transparency before projects are begun about expected impacts on people and the environment. And so on, and as well as ongoing monitoring throughout and after the project is done. So this information can inform discussions about project siting, potential project benefit agreements, and other conversations. And then on the nature pillar, one of the specific things we've been focused on, I think is also relevant in the context of California in particular, is biomass usage and making sure that the biomass that you're using is not leading to negative outcomes or emissions leakage, or taking away land area for agricultural use or reducing biodiversity. So we've been focused on identifying opportunities for that biomass, focusing on biomass waste and residues, and understanding what the kind of highest and best uses of that biomass are within the range of decarbonization options, whether CDR or not. So then I think the next question kind of becomes how do you address these within policy? So I'm just going to talk briefly about some of the ways that US policy is beginning to think about this, as well as other conversations. And then, of course, there's gaps that still remain. So the US has done a lot on carbon removal policy in the last 4 years or so. Most of the top line policy support has been focused on developing the technologies and approaches. So billions of dollars of funding in the bipartisan infrastructure law for the DAC hubs and other enabling infrastructure. And then I saw there was a question in the chat about the Inflation Reduction Act. So there was the 45Q tax credit does support direct air capture through that. But anyway, the government has made huge steps in supporting CDR, but very much from like a technology development perspective. And then I think the two other pieces that are important are ensuring there's a robust governance framework and also building demand so that someone will buy the supply that you're supporting. So on the governance framework piece, of course, existing environmental and permitting regulation apply to CDR projects. And I think, yeah, because carbon dioxide removal projects are generally not producing emissions that go into the air, they're kind of fundamentally different from and less damaging than legacy infrastructure like industrial plants or fossil fuel plants. But at the same time, we have so few examples of any type of CDR project that we will definitely need rigorous monitoring to track what their impacts are and understand those over time. And beyond that, I mentioned the direct air capture hubs were funded under the bipartisan infrastructure law, and all the infrastructure funding under that law requires community benefits plans and tracking of metrics around workforce development, equity, EJ. I'll wrap up very quickly. And then one other piece I wanted to mention was this Responsible Carbon Management Initiative that DOE is in the process of launching. That is kind of their way to get at projects that are not funded by the government. So for government funding, they can impose these reporting requirements and things that projects have to do. But for projects that aren't funded by them, this initiative is meant to provide incentives to adhere to these pillars. And then I think they're designing what those incentives are still. But anyway, it's an interesting program that's in process. And then state regulation, maybe I can skip over that for now. Just for the sake of time. And then I think just to point out a few kind of specific gaps that—
Katie, we do have to wrap up now. I'm so sorry, but
Okay.
we want to be sure
I'll
to give
stop.
enough time to everybody for Q&A. No, go ahead. You can finish. Please take one more minute.
Oh, okay. Yeah, so I guess just a few specific gaps I wanted to mention. So I think the piece about ensuring that CDR is compensating for residual emissions is really important, and understanding how policy can better address that will be critical at the international, national, state, all levels. Unified standards for measurement, reporting, and verification, including tracking of environmental impacts, is one thing that we've been working on at WRI. And we think there's an opportunity for federal government to take a role there. Within the 45Q tax credit, I think there's opportunity, though may not be politically feasible, for life cycle assessment to be included in that. And then these community benefits plans that are required under the bill, but there's no requirement to turn them into community benefits agreements at the moment. and then kind of legally binding guardrails on biomass feedstock. So these are just kind of a smattering of different gaps. There's a lot more to be discussed there, but I will stop now for the sake of
Thank
time.
you, Katie. No, that was a fantastic overview. And thanks to all of our speakers. I'll ask that all of you come on. I have a question or two for you, Katie, but we're a little bit behind time on opening it up for everybody. So I'll welcome the other panelists. Great. Thank you all so much for sharing your expertise and insights. We have a very interesting chat going on in the chat column here. But let me ask a couple questions. So first, here's, hi, Katie. Like CDR focuses on carbon dioxide, are there technologies to capture, sequester other greenhouse gases, such as methane and nitrogen oxide?
Yeah, I think there's growing interest in methane removal, or really methane destruction, which methane is a much more potent greenhouse gas than carbon dioxide, but it has a much shorter lifespan. But I think we've seen increasing emissions of methane from both anthropogenic and natural sources over time. So there is definitely growing interest. And I think there's actually a National Academies report that will come out soon looking at the state of the science and potentially a federal research agenda for that. So there's very little funding for it now, but I think there's definitely growing interest in using methane removal as a way to kind of damp down on the warming that we're seeing today, since it's so potent.
Oh, thank you. So one more question directed to Katie, and then we'll get to our broader Q&A. What are some ways, policies, or principles that allow governments to rapidly reduce emissions while also deploying CDR? So how can we ensure that CDR is not an excuse for slowing down direct reductions?
Yeah, I mean, I think that's the million-dollar question. And that's one thing that we've been thinking about in the context of those separate targets, which is if you can lay out, if you have a net zero target, how you're going to get there, what will be the roles of emissions reduction versus CDR. I think that can go, and the policy signals that will come from that will go a long way toward signaling what those relative roles are, and then ideally what that carbon removal is counterbalancing. So hopefully quantifying the residual emissions that you'll have and matching those to the level of carbon removal you're planning to build out. But I think there's a lot more to discuss on that as well.
Thank you so much, Katie. And before we get to the full Q&A with everybody, I do want to mention, because I see some questions here in the chat, that this is the first of a 6-part series for those of you who came a little bit later. This is a 6-part series on CDR. Our hope is that for the last 4, that we will cover topics ranging from community viewpoints on health and safety, as well as community benefits, governance models, responsible accounting, and policy. And we'd love your feedback in the chat about what topics you'd like to see us cover. So just put those in there. We will be saving the chat and referencing it as we decide what topics to cover going forward. Okay, so another question here for all of you is, would love to lift up the question about the Mississippi and Louisiana explosions and safety risk. What's going on with increasing the safety of these projects? Who'd ever like to go first?
I don't mind starting.
Please.
Total and complete unmitigated disaster. So what happened was the explosion of a pipeline, the rupture of a pipeline. I mentioned the risk of asphyxiation, suffocation. If it comes into your town, it pushes the oxygen out and people can't breathe. This is a disaster. This is the risk of moving any fluid by pipeline. We live with these risks now of oil and gas risks, hydrogen risks, and CO2 risks. Somebody mentioned in the chat the effects of CO2 on metals. All of these issues need to be studied really carefully. It's not obvious that large-scale movement of CO2 through pipeline can be done the way it is today. Some people think yes, some people think no. I would say that to the extent that we live in a society in which we use pipelines to transport fluids, primarily water, but also hydrocarbons, we absolutely have to think about these risks. Anyone that wants to inject CO2 underground needs to have these risks first and foremost. This will probably sound tinny, but it is the fact. It is a fact. CO2 pipelines do have a good safety record, but if you've ever worked in industrial safety, we don't want good, we want 0 accidents. And so this, frankly, is a new risk that will have to be managed. There's no way around that.
Thank you. Katie or Kim, want to address that?
I was just gonna say that PHMSA, the Pipeline Hazardous Materials Safety Administration, is evaluating their safety guidance, spurred largely because of this accident, and so that's under review now. So I think that's important, and I'm sure people in California are aware of that because of the law around not expanding CO2 pipelines until that's done. But yeah, just wanted to add that.
Yeah, thank you. Or Kim, anything?
No?
Okay, great. Before we go to more questions from our audience, I'd like to ask each of you as presenters if you have one burning question for one another. And I'll start with you, Kim. Do you have a question from listening to Katie's presentation and Marcus's presentation that you'd like to ask? And we really want to explore and push a little here. It's great to hear everything you presented. We have some really interesting questions here in the chat. And what questions do you have for your two presenting colleagues today?
I think that I'll ask my other presenting colleagues about how they consider individual projects that exist in a specific area, but then they have feedstocks coming in from other projects that have different carbon footprints, and how they think about the boundaries around individual projects and the carbon intensity.
Marcus or Katie, want to respond to that? Katie, go ahead, please.
I mean, yeah, I think whenever you're doing carbon removal, it's really important to make sure that you're counting all of the kind of offsetting emissions associated with the capture process. And this can include, like for direct air capture, for example, if you're building a direct air capture facility that has a lot of concrete, it has a lot of steel, plastic, chemicals, all of those have embodied carbon. And so those need to be accounted for, like amortized over the lifetime of the facility, as well as the kind of ongoing operational offsetting emissions from like water usage or the chemical sorbents that are needed. So I think that all needs to be counted within the life cycle assessment to inform the measurement, reporting, and verification, which I know is a future topic of webinars, to get you to what is the net removal. So you really have like clear, it's clear how much net removal there is with all of those offsetting emissions. And I think there's a lot of discussion about how to do that in credible and consistent ways at the project level, within national inventories. So it's definitely a complex topic.
Thank you, Katie. Marcus, anything you want to add?
I would add, yes, it is a complex topic. That's a technical term for it's a nightmare. Okay. I spent a couple days earlier this week with some corporate sustainability folks. People ask them things like, what are all the emissions associated with your supply chain? Where do your suppliers get their stuff that you use to make your stuff? And where do they get it? And where do they get it? Companies hate doing this because it's very difficult. And sometimes they don't even know. So if you imagine a CDR project, they are going to face the same challenge. That doesn't mean we can't push on it. We have to push on it. It's required, but it's tricky. But we can cut through all of that noise with just this one idea. It's not an accounting problem. Fundamentally, it's with this one atmosphere, we know how much CO2 is in the atmosphere. And I want to stress that no matter what your favorite approach to decarbonizing is, or even carbon removal, or you might think carbon removal is a total scam, or you might think it's all tree planting, or, we have a lot of different views. Here's a fact that's incontrovertible. The net effect of all of our efforts so far is that CO2 concentrations are going up every day. So you don't have to, what your favorite color is, they go up every day. This provenance and scope 3 and sort of supply chain problem is a really tricky one. But it is something we know how to tackle. It's just difficult and we don't want to do it, but we need to push our industry. We need to push our CDR developers. We need to push any project owner to do this, because at the end of the day, this is a public good and it's also a public health issue and the public needs to know.
Great, thank you. Kim and Marcus, Katie and Marcus, do either of you have questions that you'd like to pose to your fellow presenters?
Well, I'm not sure. To be honest with you, I would love to get to more audience questions. I think
Yes.
there were some spicy ones. So
Okay.
maybe what I could do is serve up one of those.
Please do.
Let me just like go to the hot one, or at least I was going back and forth with a gentleman called Dan and some other folks. Do you think the CDR community or industry or sector is a puppet for the oil and gas world or not? Or something else? I don't mind answering too, but I'm curious if you would like to shed any comment on that.
I think I'll get started on this one. I don't think that the carbon dioxide removal industry as a whole is a shadow or a puppet for the oil and gas industry. However, that does not by any means mean that the oil and gas industry is not having influence on the carbon dioxide removal projects and pathways being put forward. And I would also like to point out that there are other projects that are going on that are moving forward that are not connected to oil and gas. So I understand that many of the ones that people think of have oil and gas involvement, but there are, for example, even Class 6 permits being put forward by companies that are not associated with oil and gas. So I think it's just important that people realize that it's not everything. It's some projects, it's not all of them.
Yeah, I was gonna say, I think going back to the slide I had of all the different CDR approaches, I think there's definitely investment from oil companies, particularly in direct air capture among all those different approaches, but you don't really see oil and gas interest in like mineralization or ocean alkalinity enhancement, at least at this point. So I think when people talk about that, it's generally with regard to direct air capture and kind of the crossover or the applicability of expertise from the oil and gas industry and geologic sequestration. So I think this is definitely a divisive topic within the carbon removal community. There's some who think that there's no role for oil and gas to play in scaling up CDR. There's others who think they have the expertise. If we're phasing out fossil fuels, we need to move, those workers need jobs and they have this expertise. So it makes sense for them to shift into the carbon removal industry. But then I'll say even within direct air capture, you see some companies like Heirloom, the one in California, has explicitly said that they will not work with oil and gas or take money from oil and gas. They will work with ex-oil and gas employees. So yeah, I think there's a range of views. Yeah, I'll stop there.
Okay, that's great. Any other comment on this? Okay, it's a huge question, and there's no question that there's an enormous amount of influence on CDR efforts at universities and other places. It was a big chunk of funding in the Inflation Reduction Act to support CCUS, carbon capture, utilization, and storage, as well as CDR. And even in California, we passed a bill here in 2022, 905, to create some guidelines for carbon capture and storage, but it included with it CCS and almost intentionally obfuscating this issue and confusing these two. So it's not surprising that there's so many questions in here about what is the role of big oil in this and how do we then build trust? So I'm going to pull another question from our audience here. The way this person framed it is the selective adherence to IPCC calling for carbon removal while ignoring IPCC guidelines that we need to reduce emissions in half by 2030 is revealing. The chat is the response to this reality. How does this area, and I'm assuming that means CDR, regain confidence, reputation, and trust that are easily lost and hard to rebuild? Go ahead, Marcus, please.
Yeah, sure. Two things that I would say, and this goes right back to the beginning, and I think you mentioned it, Ellie, and all three of the other speakers did too. Direct emissions reductions are the priority. Carbon dioxide removal is something different. This is why we get the idea of separate targets. Now, to state the obvious, we are in conversation here talking about carbon removal. We're not here to talk about the full scope of the IPCC's work. The overwhelming majority of their work focuses on decarbonization, direct emissions reductions. However, the reality is now we have to do two things at once. And we can quibble about whether it's 99%, 1%, 90%, 10%. The point is it's not 100 and 0 now. So I would say that a focus on carbon dioxide removal is often critiqued as, why aren't you focusing on decarbonization? My response is, we are focusing on decarbonization, but we have to do another thing too. Surely we can walk and chew gum at the same time. In terms of regaining trust and credibility, I think there's a huge amount of suspicion connected to anything to do with oil and gas. Frankly, there's even a lot of suspicion to do with the IPCC. It's been under attack almost since its inception, and that's growing louder and louder. I think what we have to do is follow the data and really be fair and open about these things. So I guess just to summarize again, I don't believe it's the case that a discussion about CDR is naturally taking away from a focus on decarbonization. I would happily talk about decarbonization. The vast majority of my work has been focused on decarbonization. But CDR is another thing we've got to do. And I think it's okay to talk about it without minimizing the other issue.
Thank you, Marcus. Kim.
I'm going to ditto that and also just reiterate. We wouldn't have to do this if people had decarbonized earlier. And I personally, as a generation that was not available in a position of power earlier, find it very frustrating when people say that we shouldn't be talking about it, because I would have loved if my generation didn't have to talk about this. So just want to point out, decarbonize now, but unfortunately the bag that we have been handed includes carbon dioxide removal. I'm taking a bag that I got handed, and I think we are all collectively, all 700 of us on this call, we are taking a bag that we got handed from a generation prior for their lack of action. So we are talking about it now because decarbonization wasn't prioritized in the beginning. And we say still prioritize decarbonization first and foremost, steep reductions in emissions, but also now we need another thing.
Thank you, Kim. Katie, please.
Yeah, I was just going to say all the numbers, like all the models that we have that we look at and we say, oh, we'll need a gigaton in the US or however many gigatons globally, that implicitly includes deep emissions reductions. And so if we say a gigaton in the US, that means we're reducing emissions by however 85%. So if we don't do those emissions reductions and we still want to get to net zero, that means we need a lot more CDR, which we don't want. So it's like, the more we can do on emission, it's kind of an obvious point, but the more we can do on emissions reductions, the less we'll be reliant on CDR, which is what we want. So we have that choice now. And if you look at IPCC scenarios that prioritize near-term emissions reductions, they're so much less reliant on CDR in the long term. So we need, I think, plan for scarcity around CDR.
Thank you all very much. I appreciate the great questions and the great responses from each of you. I have another question here. How might direct air capture that is not associated with oil and gas be accelerated, either the technology or from a financing perspective? And maybe we don't have to limit it to just direct air capture. That's one of the forms of CDR, carbon dioxide removal. Kim,
Do you mind
please.
if I take this on?
Yeah, please.
Yeah, so when it comes to non-fossil related direct air capture facilities, people's support and enthusiasm goes a really long way. And also, in addition to that, in the Roads to Removal report, we specifically said we took all of the National Renewable Energy Lab, NREL's clean energy that's needed, all the cheapest, most wonderful renewable energy to decarbonize the grid by 2035. And we removed that from the playing field. We said direct air capture can't even touch those wonderful, well-located renewable energy sources. And we said you have to use the second-rate stuff and do it over local geologic storage. And so if you see projects that are happening in areas where this is the case, where they're not using that prime renewable energy, if you see companies and projects that are not related to oil and gas that you want to support, please tell them that you support them and are excited about them, because they will sincerely appreciate your enthusiasm, because it is sometimes hard to stand out as an individual project in a sea of many projects that are happening right now. So if you actually give your support to the ones that you like, it goes a long way.
Thank you. Katie or Marcus, want to add anything?
I guess I'll just say within US policy, there has been a disproportionate focus on direct air capture. We have the $3.5 billion direct air capture hubs program. The 45Q tax credit supports direct air capture at the highest credit level. It supports specs bioenergy with CCS at the industrial capture level, which is a little bit lower, but it doesn't support any other type of CDR approach. So I think there's an opportunity for more technology neutral deployment support and for more research and development. And one thing we've been focusing on specifically at WRI is increasing research and development for marine-based approaches, because we have basically no authorized funding there. NOAA, National Oceanic and Atmospheric Administration, would like to be working on that. Companies are going ahead, and we need to build the knowledge base to understand what approaches are effective, what their ecological impacts are, to inform whether that even makes sense. So we've been supportive of increasing R&D funding there. So yeah, I think policy has a big role to play in equalizing the playing field.
Great. And Marcus, anything else?
At the risk of being trite, we're in an election cycle. Vote, vote,
Mhm.
vote, vote. Climate was mentioned once in the presidential election. I wouldn't expect it to be mentioned, but I'm still grumpy about it. I'm still grumpy about it.
You mean the debate, right?
Sorry, in the debate. I
Yes,
apologize.
yeah.
In the recent debate,
Yeah.
and it doesn't look
Not
like
trite to talk about voting.
write a check if that's something you can do, but something we can all do is use whatever capacity we have, organizing in your community, asking critical questions. If you are a professional and can offer professional skills, get involved with one of these projects or a research organization or a broad organization. Legal skills, HR skills, community development, engineering skills. It's not just a technical thing. I think I would love to see the conversation shift from not that, no, 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 stop, into yes, this one, that one. We have to fundamentally at some point say yes to something. And to echo Kim, find something you can say yes to and do that. Frankly, whether it's CDR or not, but yeah, there are plenty of non-fossil CDR things we can do because we need all those things.
Thank you so much. So I've got a question focusing back on California. I think the majority of our attendees today are probably from California, but we do have people from across the country and even internationally attending today. I want to ask you, the map that you presented, Kim, in your presentation showed that the area that was best suited for underground storage of captured carbon from the atmosphere is the Central Valley. The Central Valley is also the place where there have been decades of fossil fuel extraction and pollution on frontline communities. So how do we justify that, and what kinds of community approaches what can we learn from what we've done wrong and the harm that's already been caused to do a better job with these communities in the places that the science has identified as best for underground so-called permanent carbon storage? I'll start with you, Kim, and then would love any other feedback from Katie and Marcus, please.
Absolutely. And also apologies in advance for why I keep going dark. I'm in an energy responsible room right now and I don't move enough. But assuming that you can all still see me, there's actually a term that is called fossil fuel racism, right? So this has been coined in the literature. Black and brown and low income communities have been disproportionately affected by fossil fuel extraction and transportation over the course of the entire industry's tenure and continue to be negatively impacted. So there is, in my mind, and I don't think in the literature's mind, anybody trying to say that the two are not connected. The fact that geologic carbon storage is co-located with a place that has high disadvantaged communities. Also, the Central Valley is just general geography as a bowl for really holding in a lot of poor air quality is also an issue. And it's not just even fossil fuels, it's also a lot of different infrastructure development and commercial and industrial practices. So there's a lot going on in the Central Valley. And I think that when it comes to how you can do things responsibly in a way that avoids making the same problems as you had in the past, I kind of like to think of the idea as somebody in a better position actually goes first, right? So somebody that says, yes, I'm ready and I'm enthusiastic and I'm excited to do geologic carbon storage. For example, one of the first Class 6 well permits since the Decatur project, I think was funded, it's Wabash, either Indiana, I believe it's Indiana, could be Illinois. Apologies if we have Midwesterners in here. So it's going to be exciting. I would like Californians to actually get to go out and see Class 6 wells in action. I would like people to be able to actually, there's nothing quite better than actually going and walking around something, touching your hands to it, breathing the air around it to make you feel more comfortable and excited, and also to get to know your project developers. That one is really important. Finding the project developers that have already been doing a really good job in your town. I mean, this is wonderful to get to know, and I look forward to seeing a range of different projects. I happen to know that Heirloom is open for tours in Tracy, California quite often. So go check it out if you're available to.
Thank you, Kim. Katie or Marcus? Anything you want to add to that?
I would just add sort of a little bit of awareness. Like in addition to Heirloom, let me give a shout out to a company called Captura, operating out of Long Beach. I lived in LA for many years, Long Beach / San Pedro, right by the port areas. There's sort of a marine R&D environment. You know, they're trying to this is actually about this much today, but they are trying to filter CO2 out of seawater. So their vision is something that would look like municipal wastewater treatment. You suck in seawater, filter out the CO2, put the seawater back. Why do we remember, CO2 in seawater is what's causing the ocean to be acidic. That's why the corals are dying. That's why why northern East Coast fisheries are in trouble and other shellfish fisheries. So finding projects that can be integrated into communities in a way, I think is the way forward. I spent years living in the blackest part of California, which happens to be next to the biggest oil field, the biggest urban oil field in the country, in Inglewood, California. People there don't even know about it. When I moved in, I'd ask everybody, what are these oil wells doing here? People just get used to it as the background. I think we need to talk about these projects, encourage people to ask questions. And if there are ones that make sense, because they actually bring real benefit to the community, then let's make sure the community is even aware that this is a possibility, so that nothing gets forced on them and that they're aware enough to even ask the questions.
Thank you. Okay, we don't have a lot more time. We have a couple more questions here. Can you speak to how carbon markets directly call for decreased ambition on direct emissions reductions when offset by CDR? You want me to repeat that again? So how carbon markets directly call for decreased ambition on direct emissions reductions when offset by CDR?
I may not be clear, but I think I disagree with the premise. I think the premise of the question is that the existence of carbon markets that could involve CDR take pressure off of efforts to decarbonize. Okay. If that is the premise, and I apologize if I got that wrong, I disagree with it. I disagree with it because you have to remember, why are we in this climate problem? Because it's free to pollute CO2. So the value of CO2, essentially, the market tells us, is zero. And now someone comes along and says, I can deal with your CO2 problem for a penny or $1,000 a ton, whatever the number is. It's more than zero. The carbon markets, especially the voluntary carbon markets, are an attempt to put some kind of price on that thing we don't want to value. Economists call it externalities. That's why the companies don't want to pay. They won't pay until we force them. That's why policy is so important. But the carbon markets I see as an attempt to price that thing which is unpriceable so that we can somehow consider it in our market system. It might not work. The voluntary carbon market is worth around $2 billion per year total. Global fossil fuel subsidies are $500 billion per year. That's just subsidies to subsidize the thing that we already know makes money. So I think I disagree with the premise. I don't see there's any evidence that it takes pressure off of direct decarbonization. I might have missed something. I might be wrong, but that's my first thought.
Okay, there's a clarification from the person who asked the question that it was specifically directed around low carbon fuel standard and cap and trade in California. Although the answer you gave to the broader concept was very useful and informative, so thank you. I don't know if anybody wants to respond to it specifically around California's current market system. Doesn't look like you're jumping in to address that, but maybe that's something we can, oh, go ahead, Marcus, please.
Well, yeah, so I think this is along those lines. I just happened to see in the chat that doesn't pricing give companies a way to buy out of decarbonization? My hot take for the day is I don't care how the carbon gets reduced. I care more about having the carbon reduced in the atmosphere because I know that is going to directly impact my future than saying that this group should do it or that group should do it, or that this group should take direct responsibility. So that's sort of where my focus is. I don't mean to be dodging the question, but that's sort of how I see it. The voluntary carbon markets may not work. Some people think they're a pathway to scaling this stuff. Other people disagree and think it only has to come through public action. For instance, the way we did with sulfur scrubbers in electric power. We don't really talk about acid rain anymore because sulfur scrubbers are required. It wasn't that we couldn't invent sulfur scrubbers, it's that they had no market, because why would you pay to clean up a thing that that is free to pollute? The state had to come in and say, thou shalt install a sulfur scrubber on a power station. And that created a marketplace and allowed us to put a price on it and allowed people to develop it and buy it and sell it. And now we don't talk about acid rain anymore, or at least not as much as we did in the 80s and 90s when I was growing up.
Yeah, thank you. So we are going to have to wrap up now. There are so many good questions and perspectives in the chat and from each of our expert presenters. Thank you all so very much. I'll give you each a chance just to go around the Zoom, you three, and to say one very brief vision of hope about our future. I'll start with you, Marcus, then Katie, then Kim.
The things that make me optimistic are that so many people are thinking about and focused on this topic and these broader set of climate solutions than were 5 years ago, 10 years ago. And frankly, everybody that joined this webinar, I think there were hundreds of people here today. I appreciate being challenged. I don't mind any critique. Our minds are on now and we're turned to this topic. Every week I speak to somebody that says, I want to shift my career from doing X into now thinking about climate. So it's growing in our public consciousness. We have so far to go, but young people are activated. It's now a topic in media where it wasn't 10 years ago. It's part of our culture now, and we're discussing it in places like this. So even though we have a long way to go, that actually makes me optimistic because we really can solve this problem. We absolutely have the agency.
Thank you, Marcus. We have to be brief now. Katie, please.
Yeah, I was going to say something similar, which is that how much progress we've seen on this in the past 5 years has been huge, and that's roughly the time I've been working on it. So basically going from very little policy, no policy, to what we have today. And I think there's so many groups now that are focused on these tough questions around governance, around community engagement, around MRV, around
MRV,
how to,
which means?
sorry, measurement, reporting, and verification. Yeah, so I think there's just a lot of interest in addressing these, and we're seeing movement already in policy at the national and international level. So a lot more to do, but I think we're moving hopefully in the right direction.
Thank you, Katie. And last word from Kim before I take a couple minutes to wrap us up. Please, Kim.
Right before this webinar, I was working on planting a carbon garden here at Lawrence Livermore National Laboratory. And earlier, a couple months ago, the Livermore Climate Action Plan decided they were going to take the turf removal that the state was going to pay them for anyway. And they had us cross-list the list of, 800 plants or something wild to see who would also, the state would pay them for it, and who removed the most carbon from the atmosphere and stored it deep down underground and avoided irrigation. And then that happened here in Livermore, and then the students got excited. And so now we've got 3 carbon gardens happening where it used to just be really irrigation and fertilizer prone turf grass.
Oh, Kim.
So I'm excited. We have things happening now, and in 5 years, we're hoping to quantify how much carbon just got stored deep in the soil. So
Cool.
I'm hyped.
That's great. Well, I would like everybody to please join me in thanking Dr. Kim Mayfield, Katie Lebling, and Dr. Marcus Extavor for taking their time and sharing their insights, perspectives, and expertise. Thank you all so very much. Thanks to everybody who attended today. This is just the beginning. We so appreciate your feedback and ask that you continue to put into the chat any ideas you have for how we can improve this, how we might include topics that you think are important under the broad rubric of carbon dioxide removal in the next 5 parts of our series. Again, the next webinar in the series is October 18th. It's an overview of the various kinds of CDR strategies, and somebody will drop a link into the chat so you can sign up and register for that. Separate, just to let you know, the Climate Center's own next webinar will be on a legislative wrap-up for California. That will be on October 31st. And I just want to ask you all to please join me in thanking our co-hosts, again, Melissa Romero, Grashina from California Environmental Voters, Diane Doucette from Project 2030, and all of our staff at the Climate Center who made today's webinar possible, led by Bonnie Benewal, along with Mark Victoria, Stacy Meinzen, and Pamela Martinez. Thank you all so much. We have a lot of work to do. Talking together, learning together, understanding, listening to each other is a huge step forward. So thank you for being here. Be well, have a great day and a great weekend. Thank you all.